So the next thing we're going to add into our proofs are isosceles triangle theorems. So we've talked about isosceles triangles before. We know that isosceles triangles have two congruent sides. And we know if we have two congruent sides, then we can get the angles opposite those sides to be congruent as well. So here's the isosceles triangle theorems. If two sides are congruent, so if we know it's isosceles triangle, we know these two sides are congruent, well then the angles opposite those sides would have to be congruent as well. And then the converse is also true. So if we're given that two angles are congruent, well then we know that the two sides opposite those angles are congruent as well. So the converse works for that in addition. So if we take a look at a proof here, and we are given that triangle ABC is isosceles, and we're told that the base side is AB, and we want to prove triangle DAC is congruent to EBC. So let's take a look at that, we'll mark it up, and then we'll write out our proof. Okay. So let's maybe highlight the triangles we want to prove congruent first. So DAC, we want to prove that is congruent to EBC. So let's see our givens here. So first off, we are told that ABC is isosceles with base AB. So ABC is a triangle in the middle. AB is the base, so that means that this side and this side have to be congruent because an isosceles triangle has two congruent sides. Okay, with that, we know that if two sides are congruent, then the angles opposite those sides are congruent as well. So we can get angle 2 is congruent to angle 3. But if we notice, 2 and 3 are not angles inside our triangles, the triangles we want to prove congruent. But if you notice, 1 and 2 are supplementary, 3 and 4 are supplementary. So that means that 1 has to be congruent to 4 because supplements of congruent angles are congruent. And then after that, we're told that DA is congruent to EB, and now we have enough information. We have the triangles are congruent by side, angle, side. So that would be the side, angle, side method. So now that we made our plan, we can go ahead and write out our proof. So first statement is ABC is isosceles with base AB. And if AB is the base, well then that must mean that AC is congruent to BC. And the reason why is that an isosceles triangle has two congruent sides. So if the two sides are congruent, well then we know that the angles opposite those sides are congruent. So angle 2 and angle 3 have to be congruent. And if two sides in a triangle are congruent, then the angles opposite those sides are congruent. Okay. Next, we could say that 1 and 2 are supplementary, and 3 and 4 are supplementary. Angles that form a linear pair are supplementary. Then after that, the supplements of those congruent angles would have to be congruent as well. So angle 1 is congruent to angle 4. Supplements of congruent angles are congruent. And the last piece to our proof, triangle proof, is DA is congruent to EB. So that was our last piece. So now we can go ahead and prove the triangles are congruent by the side angle side method. So triangle DAC is congruent to triangle EBC by side angle side. This next question here is slightly different, but we're still working with isosceles triangles. This time we're asked to prove that a triangle is isosceles. So in order for a triangle to be isosceles, we need to show that it has two congruent sides. Once we show that it has two congruent sides, then it has to be isosceles. So let's take a look at this example here. So we're told that angle 1 is congruent to angle 4. So 1 is congruent to angle 4. So we're not even proving any triangles to be congruent here. We're just proving that a triangle is isosceles. So 1 is congruent to 4. Well, if you notice, 1 and 2 are supplementary, 3 and 4 are supplementary, so that means that their supplements have to be congruent to each other. So 2 is congruent to 3. If 2 and 3 are congruent, well, then the sides opposite those angles would have to be congruent as well. So then AC is congruent to BC, and there we go. If we have two congruent sides, then that makes the triangle isosceles. So now let's go ahead and write out the proof. So first we have 1 is congruent to 4. Then we could say that 1 and 2 are supplementary, 3 and 4 are supplementary. Angles that form a linear pair are supplementary. After that, we could say 2 is congruent to 3 because supplements of congruent angles are congruent. After that, we said that AC was congruent to BC. And our reason was, if two angles in a triangle are congruent, then the sides opposite those angles are congruent. And then we're actually done. We proved what we wanted to prove. So we could say ABC is isosceles because an isosceles triangle has two congruent sides, and we showed that. So when you're dealing with isosceles triangles, that's really what you'll have to do, is either you'll be given that it's isosceles and you work off of that, or that you'll be asked to prove that it's isosceles.